Consider the system of linear equations given by Ax equal to b, where A is this matrix here and B is 6, 7, 8. We're going to look at the solutions to this system closely. So if you form the augmented matrix, this is what you get. And notice that this is already in reduced row echelon form, so we can read off the solutions very easily. And here are the pivots. What I can do is, I can set x2 to s, x4 to t, and x6 to u. Then I will have the solution where x1 is given by 6 minus 2s plus t minus 3u, x3 equal to 7 plus t minus 4u, and x5 will be 8 minus 5u. So again, x2 is set to s, x4 is set to t, and x6 is set to u. Now we can write this as a tuple. Now I can separate out the s, t, and u by writing like this. Okay, so this will give us all the solutions to this system. Now notice that each of these actually satisfies Ax equal to 0. And you can check that very easily. The thing is, this here is a solution to the original system Ax equal to b. So let me call this solution x star. And if I take any solution x prime such that x prime is equal to b, then what happens is x prime minus x star will give you a solution to Ax equal to 0. It's not hard to check that this, in general, is the same as this, which means this is just b minus b, and this will give you 0. So the implication of this is that if you know one solution to Ax equal to b, and if you know all the solutions to Ax equal to 0, then you will have all the solutions to Ax equal to b. You just basically take that solution that you have found for Ax equal to b and add any solution to Ax equal to 0. So in general, if you're working with a system Ax equal to b, what you do is let n of a denote. So n of a is going to be defined as all n tuples d with entries in f such that a d is 0. Again, this 0 is actually an m tuple of zeros. If x star is a solution to Ax equal to b, then x star plus d is also a solution to Ax equal to b, where d is in n of a. Furthermore, every solution to Ax equal to b can be written as x star plus d for some d in n of a. So first of all, n of a is never empty because the 0 tuple is always a solution to Ax equal to 0. The question, of course, is if we have more than one solution. And the way to determine that is quite simple. You row reduce A to a matrix that is in row reduced echelon form, and then see if every column is a pivot column. If every column is a pivot column, then you have only one solution. Otherwise, you have at least one free variable, and so you can set it to some parameter, and then obtain infinitely many solutions. So, knowing the set of D such that AD is 0 will tell you a lot about the solutions of Ax equal to b. And in fact, all you have to do is find a solution to Ax equal to b, and then find a description for n of a. And we have a means to describe n of a, and it's done by looking at the reduced row echelon form of a. Now, that's just one way of obtaining a description for this. Are there other ways to obtain a description of n of a? if I don't use Gaussian elimination, can I still obtain a description of N of A? And the answer turns out to be yes. And it will eventually lead us to the topic of vector spaces.